Hello, 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 hello. Yeah, where? Hello.
इमरान उल्टा लगा दे ठीक है
Morning.
Is that okay? The sound okay? Sorry guys, there was some technical error, and because of which we are late for 15 minutes. So anyway, we'll start now, and let me check first, and then go to the driver, and then first to remove the camera first, because hello everybody, good evening, and welcome to my class. So today I'm going to start calculus for A levels. My name is Sanjay. Okay, so before we move into understand what is the product rule and the quotient rule and the derivatives of exponential function, and similarly the derivatives of trigonometrical functions as well, for example sin x, cos x, tan x, etc. So I will highlight little on limits. So first of all, we talk about what is called limit. So here in A-level courses, we don't have to go to that detail when we start so in A-level courses we don't need the limit in fact, but in order to understand the formula we should have a little bit of knowledge from limit as well. So what is called limit? For example, if you say x and arrow and 0, that means we read this as x tends to 0. Okay, it doesn't mean that x is equals to 0. That means x is going towards 0 and it's 0. Similarly, if you are given any number n, suppose that tends to infinity, that doesn't mean that n is infinity in fact. So it is going towards infinity and at some reach the infinity. So this is called the limit. All right, and let me draw a curve. So this is curve of any function y equal to fx. So I'm taking in general, this is a curve of any function y equal to fx, and let's suppose that this is the point P and its coordinate is x, and it has y coordinate also, so y value is y equal to fx. And after some time, say this particle has reached to the point uh, x plus delta x, and then y plus delta y, and this, if you like to write in form of f, then it will be f x plus delta x. So what we can say that from point P to Q, when it is rising from point P to Q, there is a small increment in x, that is delta x, and there is a small increment in y, that is delta y. So if your x becomes x plus delta x, then your fx becomes fx plus delta x. And then by taking reference of these 2 points, let's draw a line passing through these 2 points with the x-axis, and this angle theta will be the slope of this line passing through points P and Q, that is from these 2 points. So here, if you talk about this point, this sort of thing, and the slope of this point, it will be called the secant. All right, and now let's suppose here that your delta x tends to 0, then definitely your delta y is also going towards 0. That means when x becomes 0, the q will reach to point P again here. So what is the change when q reaches P? That change is by delta x along. So what happens if q goes towards P when delta x and delta y tends to 0? This second line will become tangent. So this will become tangent. So note that if these 2 points have been joined and it has some slope, then it is called the secant. But if that line passing through only 1 point, that will now call tangent. So in order to find the slope of this line, let's drop a perpendicular over here and here, and then you can say that, look at here, from here to here it is x, and from y-axis, that is x equal to 0 to x plus 1. So what is this difference? This difference is delta x. All right, similarly this height is delta y. Okay, so in this case, if you say that tan theta, or you can say that slope m, then that is going to be equals to delta x by delta y. So here when delta x tends to 0, then definitely delta y tends to 0, because when this point moves towards P, not only delta x is going to decrease, but delta y will also change accordingly, but with its own increment. All right, so in that case, what happens? Your secant about PQ tends to tangent at point P, and this is also called the limit. So when delta x tends to 0, your delta x by delta y tends to dy by dx in general, and this is now called the tangent on the curve y equal to fx at point P, and this dy by dx is also called the gradient. So gradient or the tangent indicates that there is change in y divided by change in x. So if there is change in y and we find the value of gradient based on the change in y and change in x, that will be called the limit of the secant. That is, therefore we can write delta x by delta y. It becomes dy by dx when delta x tends to 0. That means when the function has attained its limit at point P. All right, so this is, I explained a bit about limit, but there is a lot of thing when you especially study limits. But here in A-level course, we don't need that, a little bit about limits. Now, let's talk about the product rule. So derivative of a function by product rule. Just a moment. Right. If it goes like this, no. Now be clear. Okay, guys. So we shall now talk about derivative of function by product rule. So, for example, say y equals to u times v, where both are the functions of x. You can say u as gx and v as hx, for example. So both are the functions of x. All right. All right. So if you talk about function like this, for example, if you are given function like this, y equals to say x squared plus 2 and another is under root x plus 5, for example, then this is the function of x. You can say call it u, and this is the function of x again. You can call this another function of x, and then this is v, you can suppose. Therefore, in general, you can write u equal to fx and y equals to ub, and in place of y, you can say this as fx. So one function of x is given in terms of product of two functions, gx and hx. All right, and then we'll see that how we develop formula to calculate formula to find derivatives of this sort of functions which are given in terms of product, and this will be called now product rule. So begin from here, continue from here. So you can say let delta y, delta u, delta v are small increments in y, u, and v respectively. Okay, then you can write like y equals to, you are given u and then another function as v. So what we are doing here, in y we are adding delta y, and in u we are adding delta u, close this bracket, and v we are adding delta v, close this bracket. So therefore we have now y equals to, you multiply these two, what happens, then u times v is uv, plus then u times delta v, and then multiply by this, so plus v times delta u plus delta u times delta v. And if you transpose this, this is delta y, if you transpose this y towards the right side, then it is going to be y. And then you can continue, this is u times v plus u delta v plus v delta u plus delta u delta v minus y. So you can call it is equation 1. So y equals to u times v, so you can write u times of v, and you can say here using 1. And then negative sign and positive sign of same quantity, we can cancel them, and then we are left with here u delta v plus v delta u plus delta u and times delta v. Now what you can do here, because we require dy by dx, so therefore you can do like delta y by delta x, so we divide both sides by delta x. In that case you'll have u dv plus v delta u plus delta u times delta v, and divide is equal to, we have now just separate it, so it is u times delta v by delta x, plus delta means we use for very small quantity, and this is v times delta u by delta x. So we dividing, we are making the partial fraction, or we are separating the terms by dividing by delta x, and then plus you have du times dv by delta v by delta x. You can also write delta u by delta x times delta v again. Now we can say that as, so just now we have seen the limit as delta y tends to 0, delta x tends to 0. Similarly, every small quantity will tends to 0. For example, delta u tends to 0. Then what we have seen that then your delta y by delta x will become dy by dx, delta u by delta x will become du by dx, and then delta v by delta x will become dv by dx by the rule of limits that we had just discussed here. So delta y by delta x, you can write dy by dx equals to u, and then this term dv by delta v by delta x will become dv by dx, and then plus it is v delta u will become du by dx, and plus this is du by something. So because this is already tends to 0 and there is nothing more to do about this du, so we put 0, and then this will become dv by dx. So therefore your dy by dx, where y is u times v, your formula is now u dv by dx plus v du by dx. All right. So if any function given in term of product of two functions, then in those sort of function we can apply the product rule of derivative, and our formula is this. And you'll see this formula in your Cambridge formula booklet as well, but there will be, it is written in different ways, like maybe u times v dash or v times u dash, something like this. Okay, so this is now formula to derive the function by product rule. So you have to remember this formula now. Okay, so based on this formula, now I'm going to apply this formula to the problem area. So in another side, I have one problem here. So this problem states that find the x coordinate of the points on the curve y equal to 3 minus x to the power 3 and x plus 1 whole square, where the gradient is 0. That means find the x coordinate of the points on this curve when the gradient is 0. That means when dy by dx is 0. So here you have y equals to a square. So first function of x you can call as u, and this you may say it is v. So this is now in terms of y equals to u times v, and you know the formula just now, that when y equal to uv, then if y equal to uv, then dy by dx is going to be u dv by dx plus v du by dx. What does it mean? That means you just leave it what it is for u, but and then you derive v. Here don't do anything to v, but in next time it is du by dx. So you derive, you take the derivative of u function with respect to x. All right. Okay, so continue from here. So if you use this formula, so your dy by dx is in fact dy by dx, and then this is 3 minus x cube times x plus 1 square. So we are going to derive this. So suppose first function of x as u and second as v here, and then if you apply this formula, so here in the formula you can see it is u, so you write this is u, so 3 minus x cube, and then it is times derivative of v, so this is v, so d by dx of x plus 1 square, then sign plus, and then v is now, you can see here, this is x plus 1 square, and then d by dx of, you can see here, du by dx, so u is 3 minus x cube. All right, now we proceed further, and then we can see here, so we have to do nothing with this, we don't do anything to here, so it is 3 minus x to the power cube, but we have to take the derivative of this thing. So let's see here, if you find derivative of this, that means derivative of x plus 1 square over dx, because this is a square, so you require the chain rule. So dx plus 1 square, then it is dx plus 1. So you have to see that in order to derive this, if it is x plus 1 in the denominator, there should be also the same thing like this. And then as we have taken this extra term, so we can write dx plus 1. Now we can write here dx, and then it is x plus 1. Now it acts as a single x, then you can write the derivative of x squared as 2x, x squared as 2x. So it is, in place of x we have x plus 1, so we write x plus 1, and then for this dx by dx is 1 and d1 by dx, that is constant, so derivative of constant is 0. So its derivative is 2x plus 1. Okay, so you can just bear into mind this sort of thing in order to find the derivative of this function. Okay, so what I can write it directly now, for derivative of this 2 times of x plus 1, and then in the bracket it's going to be for x, that is 1, and then for 1, that is 0, and then it is now plus, you are left with x plus 1 squared. Now we don't do anything to x plus 1 squared because nothing is given for that, but for this you have to take the derivative. So here again you have to apply the chain rule, and once you are used to of doing this sort of thing, you don't need to show the chain rule. You can just bear into your mind that how you can reach to the correct derivatives. So here its derivative is going to be 3 times of x minus 3 square, and then derivative of 3 is 0, and then derivative of x is going to be minus 1. Okay, now let's proceed further. And what are we left with here? 2x plus 1, and then this is going to be 3 minus x cube. So this is 1 only, so 2x plus 1, 3 minus x cube. Okay, plus, no, it is negative sign here, so it will be minus. Okay, because of this. So now we have then x plus 1 square, then we are left with x minus 3 square. Okay, x minus 3 square. Now let's see what we can take common out from here. So from here we can take common, this is 3 and this is 2, so it will remain here. So we take common x plus 1, and then we take common 3 minus x squared. Then inside we are left with 2 times of the, it is common out, so 2 times of 3 minus x only here, and this is minus sign, 3 times of, it has gone common, so 3 times of x plus 1. All right, and if it is asked you to find derivative, you can put answer over here, or we can simplify it a little bit. Both of the things will work, but in this case we don't do it further, or if you like you can do, yes, it is x plus 1, so 3 minus x square, and then this is 2 3 is 6, and then it is 2x minus 3x, and negative sign, positive sign, when they multiplied, that will be now negative sign, and then this is 3, and then it is x plus 1, 3 minus x square, and then inside the bracket we have 6 minus 3 is 3, and minus 2, and minus 3 is, it is minus 5x. Now your question says that find the x coordinate when the gradient is 0. So this is the gradient. So what you can write, according to the question, your gradient is 0, that is your dy by dx is 0, that is dy by dx we have seen just now here, like x plus 1, 3 minus x square, and 3 minus 5x equals to 0. So therefore x plus 1 is 0, or 3 minus x is 0, x square is 0, and then 3 minus 5x is 0, and therefore your x values are, from here it is -1, from here it is x equals to 3, and from here it is x equals to, if you transpose to here, so it is 3 by 5. So these are fine. Let me tell you one more thing from here, like, so it is x plus delta x. So what if if I write y equal to fx? So here I had taken in term of fx only. So if I write y equal to fx, then y plus delta y is going to be f x plus delta x. Okay, just like here. So here you can see that this coordinate of point P is xy. So in place of y there is fx. So we write y equal to fx as the function. And here in place of y plus delta y, we have fx plus delta x. Therefore, if you put delta y here, then x will also increase by delta x. So y plus delta y is fx plus this. And now in this case, what you can do, like another step, delta y equals to, you can write f x plus delta x. When you transpose y to the right, it is going to be y over here, and then it is f x plus delta x. Okay, I think it's okay now. Fx plus delta x minus, for y you can write again fx f x plus delta x minus fx by delta x. So as delta x tends to 0, then what happens? Delta y by delta x will be dy by dx, that we have already discussed. And then here you can write limit of delta x. So let me go this way also. It is f x plus delta x minus fx divided by delta x. Okay, and this is delta x tends to 0, means it is going towards 0. And this sort of thing also you can call as f dashed x. Okay, so therefore you can understand in either way. So if you write y equal to fx, then dy by dx equals to f dashed x. So f dashed x means, okay, it is the derivatives of fx wrt, that means with respect to x. All right, so you can also write if y equal to fx, then dy by dx is limit delta x tends to 0 f, let me write here, if, okay, if y equal to fx, then you can write dy by dx equals to f dashed x. That means f x plus delta x minus fx over delta x, and this is limit delta x tends to 0. So now we are talking of quotient rule. Quotient rule means, suppose that you are given the functions of function in term of u divided by v, where again u is function of x and also v is the function of x. So we write v equal to hx, for example. Okay, so here you see that like dy by dx equals to, directly you can write it now. So therefore dy by dx equals to, you can write in terms of this sort of thing. So you can write u plus delta u divided by v plus delta v, and then minus u divided by v. So how is it possible? Because I'm taking y plus delta y equals to u plus delta u, and then this is v plus delta v, because there is a small increment in y, there should be also a small increment in u and v, because y, x and y things will move together, therefore the changes take place together. All right, so if it is delta y, then it is going to be, so I'll write here delta y, it is going to be u plus u and v plus delta v minus y, and then so at this time I'll write delta y only. Okay, so y, so it is u plus delta u by v plus delta v. Y means again u by v, because y is given as u by v. All right, so now let's continue from here. Then it is delta y is equals to, let's take the LCM. So LCM, if you take, it is going to be v plus delta v. Now it multiplies with this, so here it is v times of u plus delta u, then minus minus it is v plus delta v, and times it is u. Okay, so v will multiply here and u will multiply here, so it's okay. So let's simplify it further. So if you multiply this, it's going to be uv plus v delta u minus uv again, and negative sign, positive sign is here. When they multiplied, that will be negative sign again. So ub and then u times of delta v, and in the denominator we have v plus delta v. Okay, and then next step is here, like ub and uv, these are plus minus, so they got cancelled out. So we are now left with v delta u minus u delta v, and divided by v plus delta v. Now let's divide to the both side by delta x here, so you have to divide here by delta x again. So when you do that, it will be like delta y by delta x is equals to, so let's divide by this. So I'll divide in the numerator, so it is v du by delta u by delta x minus u delta v by delta x. Why we have been dividing to the delta v and delta u only? Because we have to take the limit of this, so that delta u by delta x will become du by dx. Similarly, it will become dv by dx. And we have only one delta x, so we'll do nothing to the denominator. We just keep writing here dv. Now apply the limit. So you can say that limit delta x tends to 0, and here also you can write limit delta x tends to 0, and this sort of thing will become, now after taking limit, by definition of limit, it will be dy by dx, and then v, if you apply this limit over here, limit, that doesn't mean that we are going to multiply to each and every term. So wherever you find it gets fits, in that case you can write this limit. So this sort of thing will be or let's write, no problem. So where it gets applied here, so it is limit of delta x tends to 0, delta u by delta x minus u, and then you have term u, then limit gets applied here wherever it is delta value. So limit delta x tends to 0, and this is delta v by delta x, and to the denominator v plus, yes, it is dv, so limit gets, it will be applied here also. So delta x tends to 0, and then we are left with dv. So that is, or let's continue. Now let's see, as limit delta x tends to 0, delta u by delta x will become du by dx, and we have here, this is negative sign, so it is minus u, and for this sort of thing you can write this is dv by dx when limit applied here. Okay, to the down it is v, and then this is v again plus. Now let's see what happens here, also going towards 0 because v is the function of x, so that this value will be 0. So therefore your dy by dx now, that means du divided by v, that is quotient of u and v. If you find derivative of this, in that case your formula now become v du by dx minus u dv by dx, and whole thing will get divided by v times b as v square. So this is the formula to calculate or to find derivatives of the function by quotient rule, and this is not that difficult to remember, and even if you don't remember this formula, you'll find in the Cambridge formula booklet as well, that will be assigned to you in exams also. So there is no tension, there is no stress if you even forget this formula, but as this is easy to remember, better you remember this. Now based on this formula, I'm going to solve one problem. Here, so this problem states that find the equation of the tangent. Let me adjust it first. Okay, find, yes, I think you can understand now. Find the equation of the tangent of the curve y equal to, curve crosses the y-axis. Crosses the y-axis means on the y-axis all the values of x's are 0 and y has some value. On the x-axis similarly, if it is asked to do, so in the x-axis there is some value of x, but y is, first of all we have to find derivative of this, and then when you have got the expression for dy by dx, in that case we will have to find the slope, that is tangent first of all, and once you have got the slope value, then you will be able to find the given equation of line, that cross equation of line tangent at the given curve y equal to x minus 4 by 2x plus 1. So let's 1, and here you can see that this is given in terms of u and v, so it is like y equals to u divided by v. So therefore you can apply the quotient rule formula and it, but later on you just keep into mind that the formula for y equal u by v, and go directly in your in solving the problem. So here in the beginning I suggest you that to write the formula. So here your formula is y dy by dx, when y equal to given u by v, then your dy by dx will be, you have seen just now, v, then derivative of u, then derivative of v, and the denominator it was v squared, and this is u and this is v, and then I'll use that formula. So here we continue with that. So dy by dx is, in fact, we are going to find derivative of x minus 4 over 2x plus 1. Okay, so now this is u and this is v in the denominator. So first of all, we write v du by dx. You can see here that what we have calculated. Yes, first you can see it is v du by dx, then u dv by dx by v square. So now v means we just write it here, v value, so it is 2x plus 1. Then du means dx minus 4. Yes, this is x minus 4, then dx, and then term minus here. U means you again write here, what is u? X minus 4. Yes, x minus 4, then derivative of v means derivative of 2x plus 1. All right, 2x plus 1. Okay, so and everything goes divided by v square. So in place of v we have 2x plus 1, so we write here 2x plus 1 whole square. Now it is 2x plus 1 square, and then it is 2x plus 1. We have to do nothing with right as it is, because we don't need to find derivative of this function. And then the derivative of this function is going to be x has derivative 1 and 4 has derivative 0, because this is constant. And minus, it is x minus 4, and then 2x has derivative 2, and then plus 1 has derivative 0. So what are we left with now? It is 2x plus 1 times 1 is the same, minus, now it gets multiplied by 2, so it is going to be now y, and it is divided now by 2x plus 1. So that 2x and positive 2x, they got cancelled out. Now it is plus 1 and plus 8, this is 9, and divided by x plus 1. Now let's go to the question. So according to the question, yes, you may make some comment also if you like, or you may raise some question over there. Okay, according to the question, it says that find the equation of the tangent of the curve y at the point where the curve crosses the y-axis. That means according to at y-axis, where the value of x is 0 throughout the y-axis, like throughout the x-axis, y is 0. So therefore, if you put x equal to 0, your dy by dx will become 9 divided by 2 times of 0 plus 1. So that is 9 by 0 plus 1, and that is 9 by 1 is 9. So therefore, your slope is 9. Okay, and also when, because we are taking x equal to 0, when x equal to 0, then y, your y function is here, f, it is going to be 0 minus 4 and divided by 2 times of 0 plus 1. So finally it will be minus 4. So your line will pass through point 0 and minus 4, and your m value is 9. So therefore your required equation will be of the tangent. If it will ask you to find the equation of normal, you can just take reciprocal and the negative of that slope value. But here it is given that to find equation of tangent, so you don't need to reverse the slope value. So these are the 2 points. This is x value, this is y value. So by taking these 2 points and the slope value, your equation of the line is y minus y1. You know that y minus y1 equals to m times of x minus x1. So y minus y1, if you say, this is negative 4, and m value is here 9, and then x minus x1 is 0 here. So it is y plus 4 equals to 9x. You can leave it answer like this, or you can write y equals to 9x minus 4 as answer. So in this way, we apply the quotient rule to the problem area, but you have to understand that we have a lot of rule before, we have done it, but why there is quotient rule and the product rule? Because there are some kind of problem which cannot be easily broken when we deal with the derivative, or sometimes it is impossible to break. So here in this case, it is also possible that, for example, I'm telling you, like x minus 4, if you convert that into product, for example, 2x plus 1 to the power, if it goes up, then you can write minus 1. Then it is also possible that, yes, you can just expand it by using the binomial expansion, and then you multiply these two terms, and then you'll have the equation like x squared, something like ax plus b, something like this, okay? So you can do by that way also, so that you can take the derivative directly. But what happens, it requires a lot of a skill in expanding this term by using the binomial expansion. And even though you are efficient in doing this sort of work, that is the waste of time in spreading such sort of derivation. So this is not wise to just waste the time. Therefore, if you have this sort of idea, you can do the work quickly as well as easier than the usual way also. So this is the reason why this sort of methods have been developed. And also, for example, let's see, like if y equal to x plus 1 and x minus 1 is given, for example. So here you suppose this is u and v, so you can apply the formula uv for the derivative and you can find it. And this is also possible that just take a plus b times a minus b is a square minus b square, so x square minus 1. You can do this directly also. All right. So even though you can do this directly, but if you apply u or v, you have to decide that which way is going to be easier and shorter for me. So this is one reason of applying uv. And another reason is that, for example, y is given as x plus 1 and another is under root x minus 1. What happens then? In order to make multiplication like this, you have to first expand this, and it requires a lot of skill, not while using the binomial expansion. Even though if you have that knowledge of expanding, it takes a lot of time. Therefore, this is wise to go through the formula of product rule. So this is the reason why there are several formula developed in order to find the derivative of functions in different form. Okay, have a look for a while. Okay, now we shall now move further. And yes, now we'll see that how to calculate the value of how to find derivative of fx equals to ex. So this is an exponential function in terms of x, and we are going to find derivative of these functions. So here let's see, like, so here we have y equals to fx, and that is given as e to the power x, and you have to find dy by dx. So in order to find dy by dx, that means you have seen that is f dash x. Also, that is derivative of fx can be written as f dash x, and then it is limit delta x tends to 0 f x plus delta x minus fx by delta x. So I had explained you also a bit earlier, if you remember. Yes, otherwise you can reverse back and have look at this formula by first principle. This is called the derivative by first principle. So now I'll continue from here. So it is limit delta x tends to 0, and you can see here, like, fx is given as ex, then definitely your fx plus delta x is going to be equal to e to the power x plus delta x. Okay, so in place of fx plus delta x, you can write ex plus delta x minus fx, means it is ex, and by delta x, and after this term you can write limit delta x tends to 0. Now you can see here, for this ex plus delta x, you can separate its power, so it is ex times e to the power delta x. So for this you can write ex and delta x. So here in this case you can write e to the power x times e to the power delta x. You can separate the exponents, and then minus it is ex over delta x. Now take out ex common. So because ex doesn't include delta x, so we can write this is outside of limit, because limit doesn't apply. So limit apply wherever you find delta x term, and then it is limit delta x tends to 0, and then we have left with here like e to the power delta x, and it has been taken common out, so it is 1 is left here, and divided by it is delta x. Now we shall talk about this sort of thing. So what should be the value of this sort of thing? So there is theoretical way also, but at this time I'm going to explain you practically. So in order to find the value of this sort of thing, what I have done, I have taken one row for delta x and another row for this sort of thing, e to the power delta x minus 1 by delta x. And if you can see this value over here, then 0.1 is a small value because delta x is usually taken as the small increment, and another value, if you see, it is even smaller, and I kept on making the value smaller and smaller like this. That means it is going to be going towards tends to 0, so that if I'm taking delta x value very, very small, that means we can say that this is going to, it is going towards 0. That means it is tends to 0. It is also possible that you take another value of delta x like even smaller than 1, 2, 3 here, then 4, maybe 5, 6, 7, 8, 9, 10, as many zeros you can take. So you make it a small and a small so that it will nearer 0 value. That means delta x tends to 0. So let's check practically what is happening here. So as delta x is 0, then if I'm taking the calculator, and this calculator value shows that 0.1 and then minus 1 and then equal, and then the equal thing, I will divide this by again delta x, so divide this by 0.1. So this is 0.1. My value is here. I don't know whether or not you are able to see on your screen. I think so. Yes, you can. See this value on my calculator? Okay. So this value has become now 1.051709181 up to here. And I'll do the similar work for another value of delta x also, which is even less than 0.1. So I'm taking here 0.01 in place of delta x. So I'll go again to the calculator. So it is shift ln 0.01 and then space minus 1 equal divided by 0. I'm working with 0.01, so 0.01, and this value is 1.0050167 and something like this. Okay, and then I'll try for just two values also. So it is shift ln 0.01, so 001 now, and then it is minus 1 and the whole thing divided by 0. How many zeros I'm working for this? So 001. You may also calculate it. If I make wrong, then just let me know. So it is 1.000500167, something like this. Okay. Lastly, I'll try for this value also. It is 30 in front of 1 after decimal. So it is ln. No, not ln. It is exo shift ln 0.1230, then 1, and then it is minus 1 equal and divide by the same number 0. How many zeros? 3 zeros after decimal. So it is 0, 0, 0, and then 1, and my answer is SD 1.00005. Let's see now what is happening when you have kept on decreasing the value of delta x. That means delta x tends to very smaller values, and eventually it tends to 0. Okay, so have a look at value of this sort of thing as delta x has gone gradually a smaller and a smaller value, gone towards gradually a smaller and smaller values. You can see here for 0.1 it has 1.0517 like this. Another 0, if you take decimal 0 0, look at it now. You can also try for after decimal 4 0 and 1, it will be 1.00000 and 555. So you can see that as here delta x is going towards 0, your value of e to the power delta x minus 1 by delta x is going towards 1. So definitely when delta x tends to 0, then this sort of value of this sort of term will be 1. So for limit delta x tends to 0, e to the power delta x minus 1 by delta x, you can write this as ex times 1, that is ex. So therefore dy by dx, that is derivative of e to the power x, is ex itself. So there is no change in ex. So now you can remember that derivative of ex is always ex itself. Let's discuss it further. Like, so what we have noted that if y equal to ex, dy by dx is going to be dex by dx, and that is ex itself. This is the derivative of ex. Now, for example, let's see here, y equals to e to the power any number given, for example, like I'll say a in general, eax. Then dy by dx equals to what? So here in this case, what you can do, like dy by dx is e to the power ax equals to, look at here, it is ax, but here x only. So in order to find the derivative, if this is x, there should be x. That means this sort of thing will, and to the dx, here this x, both the things should be the same. And because here is ax, so you can do like this, 3ax, then you make the same thing over here, dax, because mathematically you have put the extra term, in order to match up with the derivative things, you have to balance it algebraically. So it is dx, when you cancel them, it will be balanced, and then we are left with here dx. Now for a while you can say, like, or if you are used to of this, you can do it directly. Otherwise you can say this is ax as u, and then it will be du times, you can add u also, but you don't need here, so a is constant, so a will be taken out, it is dx by dx. And then you have seen that derivative of ex is ex, therefore derivative of du with respect to u is eu, and then times it is a times of 1. So finally you have a times of e to the power u, means u we have supposed for this, so it is ax multiplied with any number. Then after taking the derivative of that function, the constant will get multiplied in the answer. And if this is e to the power negative 4x, then what will be your dy by dx? Your dy by dx will be d e to the power minus 4x. Although you require chain rule, you don't need to show that every time, but just ex, or negative 4x, but negative 4 is multiplied with 4, so your answer should also multiply by 4. So you can apply that way also directly. Okay, now let's see what happens if you are given that e to the power 2x, maybe plus, or sometimes minus also, plus 3, for example. Then dy by dx equals to what? In this case also, you have d by dx equals to dy dx equals to d by dx of e to the power 2x, plus then plus, minus then minus. You can write this way, 3. And now you can again see that these two things are not equal. So either if you feel difficulty, then you can suppose this for a while u, otherwise you can go directly as here. So it is d e 2x, so I am applying the chain rule. So I put the same thing over here in the denominator also with d, so it is 2x plus minus 3, and this is the extra thing that I put here, so I have to balance here. So it is 2x plus minus 3 over dx, and then it is e to the power 2x plus minus 3, because derivative of ex is ex, so in place of x this is 2x plus minus 3, and over also here with respect to the same thing, so we can write derivative of ex as ex. And here derivative of this sort of thing is 2 times of x as derivative 1, and plus minus, if you write, it's going to be derivative of constant, and you know that derivative of constant is 0. So your answer is 2 times of e to the power 2x plus minus 3 also. What did you notice here now? If there is plus minus, the free constant term, it has no influence in the answer, but the things that have been multiplied to the given variable will be the answer for this. If y equals to e to the power 1 by 3 x plus 2, so dy by dx will be, yes, so ex has ex, so you can write it is 1 by 3x and plus 2, and this is the coefficient of x, so you just multiply here. So this will be your answer. So in your problem area, unless otherwise stated, when you need this term, this. Sometimes you may also have to encounter the things like this. For example, I'm writing here, I hope you can see it, y equal to e to the power x squared, sorry, y equal to e to the power x squared plus 3, for example. So your dy by dx, now can you guess how you can write directly? Let's see here. Ex has derivative ex, so it is in place of x we have x squared plus 3 times, because we require chain rule here, so you'll have one more step. So derivative of x squared plus 3 is here 2x, and the answer will be 2x e to the power x squared plus 3. And you can check through the chain rule also, that how you get it. Once you become, it is x squared plus 3. Once you become used to of that, then widely also. But if this is the main part of the problem, then you have to go through all the process. You have to show the process. Okay, how do derivatives of fx equal to ln x, that is the log base e. So you have already seen that ln means log base e, so derivative for any kind of function can be found. So here you can see that y equals to, you have seen that if you write this in exponential form, it's going to be ey equals to x. Why? Because in the logarithm you have already seen that it is y, and this is ln x, means this is y equals to log base ex. So after that you can write ey equals to x in the exponential function. Okay, conversely from here, for example, let's see, if you apply from here ey equals to x, you apply ln to the both sides, so ln ey equals to ln x, and ln e means log base e, then e to the power y equals to ln x, and then using the power rule in the logarithm formula, you know that, so it is y will be in front, and then this is log base e of e equal to ln x. It has also base e, and then it is y, so the number and the base both are same, and we have also done a lot of work on this, so this value is 1 equals to ln x, and now it becomes y equal to ln x. Okay, so if ey equal to x given, you should be able to write y equal to ln x, or if y equal to ln x given, you should be able to write ey equals to x as needed. Okay, now what I do, differentiating both sides with respect to x. Then what we'll have actually dy dx of ey equals to dy dx of x. And look at here, this is y, this is x, so things are not matching here. Then by the chain rule, then it is d ey by dy, then balance this by dy, because we have put extra term dy here, and dx is already here from this term, and derivative of x is 1. Dx by dx is 1. And now you have just seen that derivative of ex is ex when it is with respect to x, so it is derivative of y with respect to y, so we can write ey and then times it is, and say this is equation 1, and then you can write dy by dx equals to, if you transpose this to the right side, then it's going to be 1 by 1, and this is 2. Y means you can write ln of x dx using 1 and 2. So therefore derivative of ln x is always, now note that this is 1 by x. And also, for example, you are given that ln of ax dx equals to what? So in that case, because it is x but it is x only, then we have to apply the chain rule. And same thing over here, dax, so this thing is the extra we have put here, so we have to balance in the numerator, so it is ax over dx. And now you know that just now we have seen that derivative of ln x is 1 by x, so in place of ln x it is ax, so it is 1 by ax, and times derivative of this thing is a is constant, it will be taken out, so a times dx by dx. All right, and a got cancelled out, so it is again 1 by x, because and times 1, so it is, yeah, here a and cancel, so times 1, it is 1 by x. Okay, have a look for a while, and you can take few more questions yourself and then try to do this. I think the net is not that good. But anyway, you can see the record later on. So you now got to know about the derivative of ln x, which is 1 by x, and you can apply this way. Now, as you know that now, derivative of ln x as 1 by x. Then what will be derivative of ln of, for example, 2x plus minus 3, if there is? Let's see what is happening here. So we apply here chain rule again. So it is ln 2x plus minus 3 over dx, no, d 2x plus minus 3, and then times it is d, because this is extra term, so it is 2x plus minus 3 dx, and after this step, so it is ln x 1 by 2x plus minus 3 times derivative of this sort of thing is 2 times of 1 plus minus derivative of 3 will be 0, because this is constant. So it is 2 divided by 2x plus minus 3. So can you note, have you noticed that what happens here? This 3 doesn't have influence in the coefficient of this sort of thing, but the coefficient of x has that influence. So this is the usual way, is that when you find the derivative of any function that where the variable contains the constant coefficient, that coefficient will get multiplied in the answer. Derivative of ln x, its derivative is ax plus minus b, and that will get multiplied with the coefficient of a, so it is a. So finally it is a divided by, it's also possible that a x cube or square plus minus b dx. So you can, although you can guess it also, but better to go in detailed process. So here again you need to apply the chain rule here. So it is ln ax cube plus minus b, then here there should be ax cube plus minus b times d ax cube plus minus b over dx, and this is 1 by ax cube plus minus b times derivative of x cube is 3x squared, so this is 3ax squared plus minus, this is constant term, free constant term, so this value is 0. So your answer is 3ax squared. By learning this, you have to do two things. One thing is that what is the actual process, what is the actual, also once you become used to of this, try to develop habit of making correct guess also. Okay, lastly I'll do derivatives of trigonometrical function over here. So by using the by first principle, that is the basic principle, or this is also called by definition. Equals to sine x. What can we write here? So here dy by dx equals to, you can write it directly now, limit delta x tends to 0, and then this is f x plus delta x minus fx by delta x, and here it is limit delta x tends to 0. So fx is sine x, so if x plus delta x means you can write sine x plus delta x minus, in place of fx you can write again sine x divided by delta x. Now say this is in the form of sine c minus sine d formula, and you know that, times sine c minus d by 2. So here we call c as x plus delta x, and d as x only, and we apply this formula sin c minus sin d formula, and that formula is 2 cos c plus d by 2, and sin c minus d by 2 you have to remember. And then when I apply the same formula, it's going to be limit delta x tends to 0. I'll keep on writing this limit until I use this. So sine, okay, this is 2 cos c plus d means x plus delta x plus d means x by 2, and then sine c means x plus delta x, and this is minus in the formula, so it is minus x, and whole thing we have is here delta x. Okay, limit delta x tends to 0, and it is 2, let's break it a bit, cos, you can see here x plus x as 2 times of x, and 2 and 2 cancel out, so it is x only, and here it is delta x by 2, and here you can see, yeah, whole thing divided by 2 here also. Positive x and negative x, they got cancelled out, so we are left with here sine delta x by 2 only, and here it is delta x. Now what you can do, like you can write limit delta x tends to 0, so where you can find delta x term, there in that place we have to apply the limit, so we apply limit over here also. So I'll write here cos x plus delta x by 2 times limit delta x tends to 0. It doesn't mean that we are going to multiply with limit, we are writing the limit where it is applicable. So it is applicable over here because there is delta x term, here is also delta x term. So it is sine delta x by 2, and whole thing divided by x, and because of this 2, if it goes to the denominator, it will be here. Now let's talk about this sort of thing. One thing you have to remember for a while, or you might have seen, that is called the Sandwich Theorem, but at this time I'm not going to prove that, so just you have to remember it, that limit theta tends to 0 sine theta by theta equals to 1, where theta is in radian measure. So this is from Sandwich Theorem, where limit when theta tends to 0 for sine theta by theta value is 1. So you have to remember this. At this point, limit theta tends to 0 sine theta by theta equal to 1. Okay, and theta is measured in radian here. So either if you have done this before, then fine. If you have not done this before, then you have to remember that this value is 1. And you can also do the experiment by taking different values of theta, that means very small value of theta in radian, and you keep on doing that value as I had done while doing the derivative for exponential function. You'll get the same situation here also, and that will that sine theta by theta will tend to 1. So that can be seen practically also. So at this time I am not that concerned to show it here, but you remember this sort of thing. So what can you write for this sort of thing here, that in place of theta there is delta x by 2, and here delta x by 2, so you can match up with this is theta and theta. So delta x by 2, delta x by 2, and here theta tends to 0 and delta x tends to 0 means even if you write delta x by 2 tends to 0, it is 2, and eventually it is 0. So it is, suppose delta x by 2 as theta, so this whole limit value will be 1 here. All right, so now put the limit over here, so it is cos x, because delta x tends to 0, so now here delta x tends to 0, not the x tends to 0, so we just keep writing x, and here in place of delta x we put 0, because this is no delta x by delta y term, something like this, this is alone, so it is exactly 0 at this point, and divided by 2 over here, and then times this value is 1, and finally we have got this is cos x. So therefore d by dx of sin x, now you remember this is cos x. And similarly if you try, you will find derivative of cos x by dx equals to minus sin x. So I'm not going to prove it here, because proof is in fact this is not necessary in A level P2 and 3 courses. And this sort of thing I have done in order to let you understand that this sort of thing are not the God gift. It has some proof here. So similarly, cos x by dx has also some method to do, and the answer is minus sin x. So note that now derivative of sin x is cos x, and if you go through the similar way, you will find the derivative of cos x as minus sin x. So the difference is cos has sin has cos, but cos has minus sign, negative sign. All right, so you have to take care of this, you have to remember. So let me discuss a bit about derivative of d tan x with respect to x equals to what. Okay, so in this case what I will do is tan x over dx, you can write here d sin x by cos x, because you know that dx tan x sin. So now you can suppose this as u and v, then apply uv formula, and your uv formula is v du by dx minus u dv by dx and divided by v square. So let's apply this formula. What happens? In place of v you have cos x times d sin x, because we have taken sin x as u, dx, then minus sin x, then this is dv, v means cos x, and then this is dx. All right, and divided by v square means this is cos square x, cos square x. Now cos x, and just now we have seen that derivative of sin x is cos x minus sin x, and the derivative of cos x is what? Can you remember? Yes, just it is sin x but in negative sense, so it is minus sin x. So minus times and down to here is cos square x, and you can see that here, like, yes, cos times cos is cos square x, and negative times negative sign is positive here, so this is sin times sin is sin square x by cos square x, and you know that sin square x plus cos square x as 1 from trigonometry, and here this is cos square x, so 1 by cos square x is sec square x. So therefore derivative of tan x is sec square x. Okay, so in this way you can find. Similarly, you can remember derivative of sec x is sec x times tan x. Derivative of cosec x is negative cosec x times cot x, and derivative of cot x is negative cosec square x. And if you apply this sort of method, you will be able to find the derivative of sec x, cosec x, and cot x also. Okay, so in sec x you can write 1 by cos x and then apply u by v formula, you can get it. Cosec x you can write 1 by sin x and then apply u by v. For u, this is, you can suppose 1 as u and sin x as v, and if you expand it by using the quotient rule formula, you will have this answer. You may try yourself. Okay, let me tell you something more about here. So for example, you have already this formula. Now for example, suppose that you are given that y equals to tan 3x. And then how do you find dy by dx? Look at here. Tan x has dy dx sec squared x. So you can write here sec squared, in place of x there is 3 times of x. Okay, but 3 is the coefficient of the variable, so this sort of thing in the answer will get multiplied. So take care of this constant. You can also see by method also, like dy by dx equals to d tan 3x by dx, or then you can apply d tan 3x. You can apply chain rule, so it is 3x times d3x, and then this is dx, and then it is tan has derivative sec square, so it is sec square 3x times, it is 3 times of 1, so it is 3 sec square 3x. So once you become used to of this method, you'll be able to write your answer directly also in the problem area wherever you need it. Okay, now for example, let's suppose that y equals to sine cube 9x, and you have to find dy by dx equal to what? So what you can do here, your dy by dx will be dy by dx of sine cube 9x. Then you apply the chain rule. When you apply the chain rule, this is sine cube 9x by d sine 9x. Why? Because people get confused here, like it is cube, so it is not x cube, it is sine cube. All right, so you have to take x as sine here, therefore, so don't get confused here. So here you have to multiply it, d sine 9x, then d 9x, because we need 9x here in place of x, and then it is d 9 dx. So it is 3-step chain rule. Now you can treat this as x now, because it is sine already here, so it is derivative of this is 3 sine squared 9x times, it is sine x now in place of x 9x, so you can write derivative sine x is cos x, so this is cos 9x, and times derivative of this sort of thing is 9 times dx by dx is 9, so your answer is 27 cos 9x sine square 9x, and this is the answer. In this way you can find. Okay, then thank you for your patience, and that is all for today. Good night. See you in some days later. Thank you so very much for attending my class on calculus.
আরেক গেছে না আপনার আগে
ল্যাপটপে অফ করে
হুম